Hello everyone, I am Nivedita Jena from Ambika Prasad Research Foundation. Welcome to all of you to our channel, Biodiversity and Conservation. So today our topic is about the meteorological parameters of Part 7 in Environmental Science of Unit 1. So let's start. So what is meteorology? Meteorology is a branch of science which includes atmospheric chemistry and atmospheric physics with a major focus on weather forecasting, and it is the scientific study of the atmosphere that focuses on weather processes and forecasting. So some basics of meteorology are pollutants circulate the same way the air in the troposphere circulates. Air movement is caused by solar radiation on the irregular shape of the Earth and its surface, which causes unequal absorption of heat by the Earth's surface and atmosphere. This differential heating and unequal absorption creates a dynamic system. The dynamic thermal system of the Earth's atmosphere also is differences in barometric pressure associated with low pressure systems with both hot and cold weather fronts. Air movement around low pressure fronts in the northern hemisphere is counterclockwise and vertical winds are upward, where condensation and precipitation takes place. High pressure systems bring sunny and calm weather, stable atmospheric conditions, with winds spiraling clockwise and downward. Low and high pressure systems, commonly called cyclones and anticyclones. Anticyclones are weather patterns of high stability in which dispersion of pollutants is pure. The high pressure area indicates a region of stable air where pollutants build up and do not disperse. And the meteorological data identifies the sources of pollutants, predicts air pollution events, and stimulates air quality using computer models. And the meteorological parameters are primary parameters and secondary parameters. The primary parameters include wind direction and speed, temperature, atmospheric stability, mixing height, and the secondary parameters cover humidity, precipitation, solar radiation, visibility, etc. So, coming to the primary parameters of meteorology, the first one is wind direction and speed. So, the dispersion of pollutant is based on the prevailing wind speed and wind direction. The higher speed carries the pollutants to longer distances, and lower speed dilution of pollutant is less. Concentration of pollutant is inversely proportional to the wind speed. Then the temperature. Temperature is a physical property of atmosphere that quantitatively expresses hot and cold. It is the manifestation of thermal energy. The temperature is measured using mercury thermometer, which works on principles of thermal expansion. If thermometers are useful up to 50 degrees Celsius. And then mixing height or mixing depth signifies the height above the surface throughout which a pollutant such as smoke can be dispersed. And during times of surface temperature inversions, which typically nighttime with clear skies, the mixing height goes to zero and smoke dispersion is minimal. Then the stability. The lapse rate is the rate at which an atmospheric variable normal temperature falls with altitude. The environmental lapse rate is the rate of change of the temperature, the environment with changing altitude, or the lapse rate of non-resin air. The adiabatic lapse rate is the rate at which the temperature of an air parcel changes in response to the compression or expansion associated with elevation change. The actual stability of an air parcel is determined by the orientation of the environmental lapse rate in comparison with either the dry or moist adiabatic lapse rates, and the stability is associated with how air parcels behave once they are displaced vertically from their initial positions. The three types are stable or positively stable, neutral. The second one is neutral or neutrally stable, and the third one is unstable or negatively stable. So the stable or positively stable implies that a displaced air parcel will return to its initial position associated with high pollution, and the environmental lapse rate is smaller than the adiabatic lapse rate. Then the second one is neutral or neutrally stable, which implies that a displaced air parcel will remain at its new position associated with moderate pollution. Environmental lapse rate is equal to adiabatic lapse rate. And the third one is unstable or negatively stable, which means that a displaced air parcel will continue to accelerate away from its rest position associated with low pollution. So the environmental lapse rate is greater than the adiabatic lapse rate. So let's know about the stability of the atmosphere briefly. We have already learned about the hydrostatic equilibrium of the atmosphere, which is the balance between the vertical component of the pressure gradient force and the gravity. In case of hydrostatic equilibrium, there cannot be any vertical acceleration, but in case of weather phenomena like turbulence and convection, there will be vertical movement of the air. Hence, we have to study the forces which come into play in case of such phenomena in which the hydrostatic equilibrium gets violated. And before going into the details of the stability or instability of the vertically moving air, the details regarding the lapse rate can be looked into. And it is found that the temperature in the troposphere normally decreases with height. The rate of decrease of temperature with height is known as the lapse rate or the environmental lapse rate, which is termed as shortly ELR. In case of moist air, the lapse rate of the virtual temperature is considered rather than the actual temperature, and when the temperature is falling with height, the lapse rate is positive. In the troposphere, occasionally there can also be layers in which the temperature increases with height. This is known as temperature inversion. In an inversion layer, the lapse rate will be negative. Even though the lapse rate varies in the atmosphere, it can be approximated as a constant for a layer, and the virtual temperature and the altitude at the bottom and top of a layer respectively, and gamma v is the constant lapse rate for the layer. Then the adiabatic lapse rate. Within the environment, we may consider certain parcels of air which is moving up or down adiabatically. Since the movement of the parcel is adiabatic, the rate of fall of temperature of the parcel will be different from that of the environment, and that corresponds to the parcel lapse rate. The vertical movement of the parcel and whether the same will be stable or unstable can be determined by comparing the lapse rate of the parcel and that of the environment. Then here the environmental lapse rate is the temperature change with height that is recorded by a weather balloon, and the environmental lapse rate average is 6.5 C per kilometer, and thus ELR is frequently conditionally unstable, and it is often absolutely unstable in a thin layer just above dry ground on hot, sunny days. And the temperature of air decreases with increases in height above the surface of the earth, and the rate at which decreases in temperature with increase in height is termed as environmental lapse rate. It, the lapse rate varies from height to height. Thank you.